This project focuses on an AI-based chargeback denial assistant for a pharmaceutical distributor. The main idea is to use machine learning as a co-pilot for chargeback analysts, rather than using it to make financial decisions automatically. The approach has 4 parts. First, I look at the current task and where analysts spend most of their time. Second, I design how users would interact with the AI recommendations. Third, I consider privacy and data protection. Finally, I look at potential bias and the broader ethical AI controls. Throughout the process, the analyst remains responsible for deciding whether a denied chargeback should be recalculated, corrected and resubmitted, dropped, or escalated. Pharmaceutical distributors receive a large number of denied chargebacks that need to be investigated. To understand the denial, an analyst may need to review claim details, contract eligibility, customer and material data, pricing information, and manufacturer rules. The current process usually starts when the analyst receives a denied claim. They review the denial reason, gather information from different systems, determine the likely root cause, and then decide the next action. The main insight from the task analysis is that data collection is often the biggest bottleneck. Analysts spend a lot of time finding and connecting information before they can actually apply their judgment. This is where AI can help. It can prioritize the claims, identify common patterns, and bring the most relevant evidence together in one place. The proposed solution would be built into an analyst workbench. The model would use information such as claim attributes, denial codes, contract eligibility, customer and material data, price dates, and outcomes from similar past claims. For each denied claim, it would provide the likely root cause, a recommended next step, a confidence level, supporting evidence, and similar past cases. The analyst would then review the recommendation and decide what to do. They could accept the recommendation, override it, select the actual root cause, and add notes. This feedback would be important because it creates a learning loop. However, the model should only learn from cases that have been reviewed and completed by an analyst. Next, we see what the chargeback denial workbench could look like. On the left, the analyst sees a prioritized queue of denied claims. Each claim has a priority level and a possible root cause. When the analyst selects a claim, the system shows the manufacturer's denial reason, the predicted root cause, and the recommended action. In this example, the model predicts a contract eligibility mismatch with 74% confidence. Since the confidence is only medium, the system also shows alternative explanations. The analyst can also see the evidence behind the recommendation, such as an inactive contract date or similar prior denials. The important point is that the system does not hide uncertainty. It gives the analyst enough information to question the recommendation and make the final decision. From a privacy perspective, the model should only use the data needed to resolve chargeback denials. This includes operational claims, contract data, pricing history, denial details, analyst notes, and final outcomes. The model should not require patient-level information, so those fields should be excluded. Other important controls would include role-based access, retention limits, audit logs, and tracking which model version produced each recommendation. HIPAA would need legal review if protected health information was being handled on behalf of a covered entity. However, even without patient data, the contract and pricing information is commercially sensitive and still needs strong protection. The main ethical risk is that the model could learn incorrect or unfair patterns from historical data. For example, past analyst decisions may reflect outdated processes. Smaller customers or rare denial reasons may also have fewer examples, which could reduce model accuracy. The model may also rely too heavily on variables such as customer type, region, or manufacturer. To support fairness, performance should be tested across different customer groups, manufacturers, denial types, and claim sizes. For accountability, there should be a clear model owner, prediction logs, model documentation, and human responsibility for the final action. For transparency, analysts should be able to see the model's recommendation, confidence level, supporting evidence, and alternative explanations. Overall, the goal is not to replace the analyst. It is to reduce manual investigation effort while keeping human judgment and accountability at the center of the process.